In this lesson, we're going to learn about how to use the commutative and the associative properties. So what are the commutative and associative properties? Well, we'll start with the commutative properties. So there's going to be some language in this definition that I'll explain as we go, but I'm just going to read through the whole definition first, and then I'll go back and re-explain the language. So the commutative property of addition is if A and B are elements of the real numbers, then A plus B is equal to B plus A. Similarly, the commutative property of multiplication is if A plus B is equal to if A and B are elements of the real numbers, then A multiplied by B is equal to B multiplied by A. So let's break down these definitions and I'll give you a little bit of context by what I mean by all this. So we remember from the lesson in regards to integers, rationals, irrationals, and the real numbers. We all know what the real numbers are. They're a combination of all of those, the integers, the rationals, the irrational numbers. So if A and B are what we call elements, or if A or B are a part of the real numbers, which means A and B are either integers, they are rational numbers, they are irrational numbers. So that's what we mean by this phrase, and that's what this kind of goofy looking R stands for. If you ever see this goofy looking R, that's what it's supposed to be as an R. You know, it looks better in textbooks, but when you have to write it by hand, it might not look very good. But that goofy little R means the real numbers. And this goofy E looking number, this goofy E looking symbol means elements of. These are concepts that really get hammered home, especially in college, but I figured I would introduce it to you as I don't think they're anything too complicated. So if A and B are elements of the real numbers, so if A and B are integers, rational numbers, or irrational numbers, if A and B are elements of the real numbers, then A plus B is equal to B plus A. So that means if I take any number, let's say 5 plus 7, that is the exact same as 7 plus 5. Now that seems pretty intuitive because 5 plus 7 is equal to 12 and 7 plus 5 is equal to 12. So these properties aren't anything too complex. We just put a name on them. That way we can refer to them more simply. So all this is really saying that is if A and B are real numbers, then A plus B is equal to B plus A. Nothing too complicated there. This same exact concept works with multiplication. So if A and B again are part of the real numbers, if they're integers, rationals, irrational numbers, if A and B are elements of the real numbers, then A multiplied by B is equal to B multiplied by A. And again, we can see that in, say, 7 times 9 is equal to 9 times 7. 7 times 9, that's 63. 9 times 7, that's 63 as well. So again, this commutative property, it's nothing too complex. It's just stating something that is fairly simple. Now, you notice that we only have commutative properties of addition and multiplication. Why not for subtraction or division? Well, let's go through that. So let's look at subtraction. Well, if this associative property would hold the same for subtraction, then we could say 12 minus 5 would be equal to 5 minus 12. Well, if we look this, 12 minus 5 is equal to 7, but 5 minus 12 is equal to negative 7. And those don't equal each other. This would be true for any sets of real numbers. So for this reason, subtraction is not a part of the commutative property, okay? So again, there is no commutative property of subtraction, only commutative property of addition. Okay, what about division? Is this kind of the same idea? So the commutative property of a division, okay, that would be, say, 100 divided by 20 would be equal to 20 divided by 100. Well, 100 divided by 20, that's equal to 5. But 20 divided by 100, that's 1 over 5. Oh, well, those don't equal each other either, because obviously 5 does not equal the same as 1 over 5. So for this same reason, there is no commutative property of division. Again, no commutative property of subtraction or division. There's only the commutative properties of addition and multiplication. Again, this isn't a very complex idea. It's just we're putting names on something that is fairly intuitive and simple. And again, that is, if A and B are elements of the real numbers, then we can add them in either order, or we can multiply them in either order to get the exact same answer. The next one we're going to go through is the associative property. Again, this is very similar to the last one, only now we are using 3 different numbers instead of 2. So, the associative property of addition is if A, B, and C are elements of the real numbers. Again, we went over that. That means they're integers, rationals, or irrational numbers. If A, B, and C are elements of the real numbers, then A plus B, in parentheses, plus C is equal to A plus B plus C in parentheses. The same concept works for multiplication, the associative property of multiplication. If A, B, and C are elements of the real numbers, elements of the integers, rationals, or irrational numbers, then A multiplied by B, then multiplied by C is equal to A multiplied by, well, B and C together. So what do I mean by this? What is this statement even saying? It seems pretty abstract, or what are we talking about here? Well, let's go through this. So say we had 3 plus 4 plus 8. We're saying that's equal to the same as 3 plus 4 plus 8. Again, this is the associative property of addition. So why do I keep throwing parentheses around this? Well, what this is really saying is if we have 3 numbers and they're all elements of the real numbers and we're adding them all, then it doesn't matter if I add the first 2 numbers together, say 3 plus 4 is equal to 7 plus 8, or if I add the second 2 numbers together, first 4 plus 12. Because if you notice, 7 plus 8 is equal to 15, which is equal to 3 plus 12. So that's all that the associative property of addition is talking about. If we have 3 numbers and we're adding them together, it doesn't matter if we add the first 2 together, then the third to their sum, or if we add the second and third together, and then the first to their sum. It will all equal the exact same thing. So again, if you're using addition and A, B, and C are part of the real numbers, it doesn't matter if we add the first 2, then the third, or the first, then the second and 2 at the same time. You can add them all in any order you want because it will give you the exact same answer. Similarly, for multiplication, if we have 5 times 2 times 3, that will be equal to the same as 5 times 2 times 3. Okay, because 5 times 2, that's 10 times 3 is equal to 5 times 2 and 3 is 6, which is equal to 30 is equal to 30. Again, if you have 3 numbers, A, B, and C, and they're all elements of the real numbers, then it doesn't matter if we multiply the first 2 together to get an answer and then multiply it by the third, or if we multiply the second and third together, then multiply them by the first, it will be the exact same thing. So again, the very core of the associative property is if you have 3 numbers that are all of the real numbers, then it doesn't matter, and you're multiplying them all together or you're adding them all together, it doesn't matter what order you do that in. That is what the associative property does for us. And again, similarly, this would not work for subtraction because say we had 7 minus 3 minus 2, that would not be equal to the same as 7 minus 3 minus 2, because 7 minus 3, that's 4, minus 2, 7 minus 3 minus 2 is 1. Well, that's equal to 2 does not equal 6. So again, the associative property does not work for subtraction. Similarly, if we do it for division, we could have 8 divided by 2 divided by 3. Well, or we could do 8 divided by 2 divided by 3. Well, that's equal to 4 divided by 3. That's equal to 8 divided by 2 over 3, which again would be equal to 4 divided by 3, 8 over 1 multiplied by the reciprocal, 24 over 2, which is equal to 12. So 4 over 3 does not equal 12. So again, this is just an example of why the associative property does not work with subtraction or division. The associative property, like the commutative property, only works with addition and multiplication. Again, these are fairly intuitive ideas. We're just now putting names to something that we've always kind of talked about.